Hey everyone, I am super excited to introduce you to this next ARKit section where we are going to learn about image tracking. So check out the app we are going to build. We have two cards here, the Queen of Diamonds and the King of Hearts. They are overlaid with a semi-transparent plane, and a diamond appears over the Queen and a heart over the King. We are going to learn about what makes a good image to use for image tracking. We're going to learn how to know when an image is detected, how to add objects to it, and even make them take action when they get close to each other. So this is going to be a super fun section, so let's jump in. Hey everyone, welcome back. Let's get started with this awesome image tracking app, shall we? I'm going to create a new project and select Augmented Reality App, say Next. And I'm going to call this Hearts and Diamonds. I'm going to say Next, make sure Scene Kit's selected. Just going to put this on the desktop and say Create. All right, so let's go ahead and do our usual. I'm going to clean up some of this stuff that we're not going to be using. Delete the ship and its texture. Then let's open up the view controller and just going to get rid of all these comments and things we're not using. We can get rid of all of that actually. And then get rid of some of these comments, this comment, and then we are going to just delete the rest of this. All right, great. All right, so in this lesson, in this section, we are going to be detecting images, right? Now I got my two cards here, the King and Queen, that we are going to be working with. If you don't have a deck of cards, you can use anything, business cards or Uno cards or whatever type of image that you want. It doesn't have to be these. You can still follow along just fine, okay? But before you go and get whatever image that you are going to use, there's a couple of things that you should know about image detection, all right? So image detection has its limits, it's not perfect. And so you can help it be able to detect the image as well by providing good images for tracking. So what makes up a good image? Well, for one, it has distinct features, it's well textured, and has good contrast. This is the image that they provided, that Apple provided as a good example of an image for tracking. You can see that it's vibrantly colored, lots of interesting things, lots of detail. Bad images, on the other hand, have repetitive structures, uniform color regions, and a narrow histogram. And a color histogram is a representation of the distribution of colors in an image. So this image would have a narrow histogram, okay? And we can actually test that pretty easily right here in Xcode, and it will give us feedback. So go into your assets.xc assets. Well, actually, this is just to show you. You guys probably don't have these images. But if where we're going to put our images that we want to detect, we're going to come into our assets and say new AR resource group. Okay. And then just to show you how Xcode will help, I'm going to drag in these two images right here. Okay. And the first thing it's going to tell us is that these images need size dimensions, okay? And this isn't really important right now. We'll go over this more here in a little bit. But what I want to show you is if you put in an image that image tracking is going to have a hard time detecting, you'll see this yellow warning here. And if you click on it, it will kind of tell you why. And this one has just about all of the bad things. It says that the histogram of the image is narrow or not well distributed. Recognition works better on images with wider, flatter histograms. This one has repetitive structures. So recognition works better on images without repetitive structures. And the image has uniform color regions, low texture or low contrast regions. So pretty much this is the worst image that you could have. And you'll notice that on the good image, there is no such warning. Okay, so that would be one that image tracking would have an easy time detecting. All right, so that was just to show you the warning sign that you might get if you happen to choose an image that image tracking doesn't like. And if you get that, then you know you're just gonna probably have to get a different image to work with. All right, so I'm going to delete those two. And now let's go ahead and get the images that we are going to work with, okay? So like I said, I have my king and queen cards here, and I'm just going to snap a photo of them on my camera, on my iPhone. And so you might choose to do this differently. If you have something that you want to just print off of the internet, that's totally fine. But I'm going to go ahead and take some pictures here, all right? So something to keep in mind is that you want to try and make sure that you aren't getting any glare. So let me try and block that light right there. And there we go, gonna take that right there. Then I'm gonna open it up and I'm just going to edit it right here on my phone. Just gonna crop it a bit. Looks pretty good. A little bit more on this corner. Rotate it a little bit, then crop it again. Okay, that looks pretty good. Then I'm going to see if we can find a filter here that makes this look better. And I'm using the Vivid Cool one. It's one that I found while experimenting that I think kind of lightens it up and makes it look pretty good. And then I'm going to say done. And I'm just going to go ahead and airdrop this to myself. You can, if you don't have that, you can email it to yourself or chat it to yourself, however you want to get it to your computer. All right, and then we have the queen. So I'm going to go ahead and also take a picture of her card. See if I can get rid of that glare right there. And all right, take that picture. And let's go ahead and edit this one as well. Go ahead and crop it. Let's try and rotate it just a little bit. Probably not going to get it too good. All right, let's just crop it there. And there as well. It doesn't matter too much about the size because the main part that it's going to be looking at is right in the middle where all of the color and intricate details are. So that should be fine for us. So I'm going to say done, and then I'm going to airdrop that to myself again. All right, perfect. So now I have those two images in my downloads folder with my Xcode project open and the AR resources folder right here. I'm going to drag both of those images into my AR resources folder. And I realized I forgot to apply that cool image or a filter to my queen image, but we'll see if that causes us any problems. All right, so I'm going to select the king. And here in the AR reference image, we have some properties that we can change. We can give it a name. So I'm just going to call this king. And then you'll see here this size, okay? So this is the physical size of the object in the real world, all right? So we need to provide it a width and a height so that image tracking knows what sort of size of this image it should be looking at. That will help it detect it as well as provide us some information if we want to, say, overlay a scene plane on top of it, which we're going to do. All right, and I measured this and found it to be about 2.5 inches, okay? So this is crucial that you get the units here correct. Otherwise, later on, we'll get all mixed up here, okay? And all you really need to do is provide one of the dimensions. I'll do the width of 2.5 inches, and then it calculates the height for you based on the aspect ratio of the image. So that's pretty nice. And so our king looks good, no warning signs, so we should be good there. Now I'm going to do the same thing with the queen. I'm going to rename it to queen and set the size to 2.5 inches wide. Oh, got to put the select the unit first. There we go. 2.5 inches. All right, so now we have both of our images that we are going to want to detect here in our AR resources folder, and we can rename this, and I'm going to call this playing cards. Okay, And you can actually have more than one AR resource group. It's recommended that you only have about 25 in each group, okay? So if you have an app where you need to hold a lot more than that, then you'll probably need to create more of these AR resource groups and then find a way to know when you need to switch between the two. So for instance, in the WWDC talks, they talk about using this in a museum. And so for instance, you have a whole bunch of rooms with a whole bunch of paintings. You would have an AR resource group for each room, and then you would use geolocation to determine which room or region they're in, and so then you would know which AR resource groups to load and to check against. All right, so in this lesson we talked about what makes a good and bad image. Good images have distinct features, are well textured, and have good contrast. Bad images have repetitive structures, uniform color regions, and a narrow histogram. And Xcode will help you know if your image is good or bad. All right, so in the next lesson, we are going to learn how we can actually detect these images in the real world. So hope you're excited for that, and I'll see you in the next one. Alrighty, in the last lesson, we went ahead and added our 2 images that we are going to be tracking. Now we need to have a way of actually telling our app to track them and a way of knowing when they are detected, okay? So the first thing we're gonna do here in the view controller is we're going to enable our lighting. So we're going to say scene view dot auto enables default lighting. Let's go ahead and set that to true. And then we're going to take a look at our configuration. Up until now, we've been using the AR world tracking configuration. This time, we are going to use the AR image tracking configuration. Okay, so let's take a look at it and see what the differences are. So if you go to the quick help and then let's open this in the developer documentation, it says here that all AR configurations establish a correspondence between the real world, the device inhabits, and a virtual 3D coordinate space where you can model content. When your app displays that content together with a live camera image, the user experiences the illusion that your virtual content is part of the real world. With AR image tracking configuration, ARKit establishes a 3D space not by tracking the motion of the device relative to the world, but solely by detecting and tracking the motion of known 2D images in view of the camera. Okay, so it's a little bit different. AR world tracking configuration takes into account the movement of the device in the world. AR image tracking only looks at the known images and the motion of those images in view of the camera. AR world tracking configuration can also detect images, but each configuration has its own strengths. Okay, so world tracking has a higher performance cost than image only tracking. So your session can reliably track more images at once with AR image tracking configuration. And that's because it's keeping track of a whole lot more stuff if you're doing AR world tracking configuration versus just looking at these images. Image only tracking lets you anchor virtual content to known images only when those images are in view of the camera. World tracking with image detection lets you use known images to add virtual content to the 3D world and continues to track the position of that content in world space even after the image is no longer in view. Okay, so if you need your virtual content to persist longer than when you're looking directly at it, then you might need the AR world tracking configuration. World tracking works best in a stable, non-moving environment. You can use image-only tracking to add virtual content to known images in more situations. For example, an advertisement inside a moving subway car. All right, so those are some of the main differences between AR world tracking configuration and image tracking. There are pros and cons to each. Alrighty, so we've set our configuration to AR image tracking configuration. Now, how do we let the configuration know what images to look for, okay? So the way we do that is we say if let, and I'm going to call this tracking images, is equal to, and we call AR reference image dot reference images in group named. Okay, so we are now looking for this group right here called playing cards. So right here I'm going to say playing cards, make sure it's spelled right. And then the bundle is the main bundle. So I'm going to say bundle.main. Okay, so if we are able to obtain that group of AR reference images, then we're going to say configuration.tracking images is equal to tracking images. And if we click here, we see that this is a set of images for ARKit to detect and track in the user's environment. And then we can say configuration.maximum number of tracked images. All right, so this is just to let ARKit know how many images to track. And we're going to start out with 2. All right, and then we go ahead and start the session. All right, so that's all well and good. So now ARKit will be able to detect the images because we told it what images to look for. But how do we know when it has detected one of these images? All right, so we're going to need one of our AR scene view delegate methods, and that is node4, okay? And it says that this asks the delegate to provide a SceneKit node corresponding to a newly added anchor, okay? So what is an anchor? Let's go ahead and check this guy out here in the developer documentation. Now, an AR anchor is a real-world position and orientation that can be used for placing objects in an AR scene. So this method is called when ARKit detects and adds an anchor, okay? And it expects to return an SCN node. So let's go ahead and create ourselves a node here. I'm going to say let node equal SCN node, okay? And then we're going to do a check for the type of anchor that is returned, because this will create anchors for horizontal planes, vertical planes, if those types are being detected. If we're working with image detection, then it could also add anchors for AR images. So we want to make sure that the anchor that we're going to be working with is an AR image anchor. Okay, so I'm going to say if let image anchor is equal to anchor as an AR image anchor. Okay, so we are grabbing this guy right here that we get from the method, and we're just going to see if it is an AR image anchor. See if it's an anchor that has been added as a result of detecting one of our images. And then down here, to get rid of this error, I'm going to say return node. Okay, so we have now an image anchor, and let's check out the AR image anchor. It says here that when the session recognizes an image, it automatically adds to its list of anchors an AR image anchor for each detected image. To find the extent of a recognized image in the scene, use the inherited transform property together with the physical size of the anchor's reference image. Okay, so that's interesting. We can get the physical size from this anchor, the physical size of the detected image. So I'm going to say let size equal image anchor dot reference image dot physical size. And then what we're going to do is, remember from our introduction, we are overlaying a semi-transparent plane on top of our image. All right, so let's go ahead and initialize an SCN plane. Let's say let plane equal SCN plane. And we're going to initialize that with a width and a height. And the width is our size, which we get from the reference image dot, let's see, is this width? Yeah, width. And then the height is size dot height. Okay, so let's go ahead and give this a material. So I'm going to say plane dot first material. We're going to go ahead and do it with the one line way. Diffuse dot contents is equal to, and we're going to give this a UI color. And we're going to do something a little bit different than we may have seen before. We're going to say white, and then we're going to say dot with alpha component. So you can append this with alpha component to any color and directly give it an alpha value. And we're going to make this semi-transparent, so I'm going to say 0.5. And then we can make it look nice by giving it a corner radius. So I'm going to say plane.corner radius is equal to, and we'll go about 5 millimeters, so 0.005. And then once we have our geometry complete, we need a node to attach it to, right? So I'm going to say let plane node equal scene node, and we will initialize it with the plane geometry that we just created. And then we can go ahead and add this plane node to our node that will be returned from this function here. So I'm going to say node.add child node, and we're going to say plain node. All right, and if all goes according to plan, we should see a plane that is generated when we detect one of these images. All right, so let's check it out. All right, so it's asking us for permission. We say okay, and there we go. So now we can see here that we are detecting this on the king, and you can see our plane. Okay, so one thing about planes is that they are always created in the vertical orientation. So we're going to need to rotate this 90 degrees around the x-axis, so negative 90 degrees to get it laying down. Let's see if our queen is detecting, and oh, yep, she's detecting as well. All right, perfect. So our detection is working, and we're adding a plane. How stinking cool is that? All right, so let's go ahead and rotate these planes 90 degrees. So before we add it to our node, let's go ahead and rotate it. So we're going to say plane node dot Euler angles. Okay, so this is the node's orientation expressed as pitch, yaw, and roll angles in radians, and this is animatable. Okay, so if you're not familiar with pitch, yaw, and roll, you can kind of think of it like this. When you're in an airplane, or you see an airplane, and you talk about a barrel roll, they're doing a roll, right? So that is the orientation that rotates around the z-axis. If you see an airplane and it's going up and down, that is the pitch, okay? That would be the nose going up and down. Yaw, that's about the only direction that you have available to you in a car, okay? You're just turning left and right, okay? And that would be rotation around the y-axis. So we are going to rotate this around the x-axis. So we're going to say Euler angles dot x is equal to minus dot pi divided by 2. All right, and then we add it to our node, and let's go ahead and test that again. All right, that looks like that is working out very nicely. Yeah. Detecting on both cards, and we have a nice overlay. That looks great. All right, so just to recap, in this lesson, we talked about the differences between the AR image tracking configuration and the world tracking configuration. We learned how to get the images inside of our AR references group, and how to add those tracking images to our configuration and set the maximum number of tracked images. Then we learned how to know when an anchor is added to our scene, and more specifically how to check to see if that is an AR image anchor that we can use. And then we learned how to create and add a plane, making sure that we can rotate it around the correct axis to make it lay flat on our image. All right, so I hope you enjoyed this one, and in the next lesson, we are going to actually go and get our models of the heart and diamond, all right? So I hope you're excited for that, and I'll see you in the next one. Hey everyone, welcome back. In the last lesson, we were able to go ahead and add our plane transparent overlay over our detected images, and now we are ready to, if you remember from our demo, we had a heart and a diamond floating above our cards. So now is the time to actually go and get those models, all right? So real quick, let's talk about what kind of models are supported in ARKit. Out of the box, you will find that .dae, which comes from the 3D modeling program Collada, and .obj files are the most compatible with SceneKit, okay? So when we're looking for 3D models to use, we're going to try and focus on those two types. So if you are like me, then you aren't also a 3D artist. If you are, that's awesome. You can do some incredible things with your own creations, and so you are very lucky there. But for those of us like me that aren't, we need to go and find 3D models for us to use. And I found, I'm showing you 3 websites here that have some free 3D models. Not all of them are free, but a lot of them are, okay? So the first one here is free3d.com. And they have a lot of models here, right? And they have them broken down into types. So you could search for OBJ models here. I'm not sure if they have any .dae models on this site, but OBJ models work pretty well. And then over here we have Turbo Squid, and this one is probably the most fancy models. They have some really nice ones. A lot of them are rigged, which means that they are animated and animatable. The last one that I'm going to recommend here is 3dwarehouse.sketchup.com. And they have a lot of good free models here as well, all right? So let's take a look at how to actually go about downloading one of these. I'll download one here from 3D Warehouse. If you're not familiar with the types of materials and UV layers and normal and all that kind of stuff that goes into 3D modeling, which I am not an expert, then I would recommend sticking with some very simple models here. So I'm going to search for diamond because we have a queen of diamonds. So I'm going to search for a diamond. And I think that, let's find a good looking one here. This one looks fine. So I'm going to click on it. And you'll see here we have a download button. And we have SketchUp models. And we want this one right here, the collada file, because that's going to give us a .dae file. Okay, so I'm going to click right there. And I'm just going to drop that on our desktop right here, and you can see here that it says model-3.dae, and I'm going to change that to diamond.dae, and then I'm going to open Xcode back up, and I'm going to grab it and drag it and drop it right here in my art.sceneassets file. And now we can check out this .dae file. Here we can see the diamond, kind of. So let's go ahead and take a look here. First thing I'm going to do is convert this .dae file into a SceneKit file format. So I'm going to say convert. And now this is in the form that we're familiar using, a .scene file. And we have two nodes here. And you can actually, this is a camera, so we don't really need that. So I'm just going to delete it. And then I'm going to rename this node, rename this to diamond. Okay, now it's kind of hard to see the diamond, so I'm going to go ahead and come over here to our scene inspector, click here and say background procedural sky. Okay, and then we can see it a little bit better, but we still can't see it very well, and that's because let's check out our materials here. Oh, I got to select it. And we can see that our shading, if we set it to physically based, then we can see that significantly better. All right, and there we have it. We got ourselves a diamond. Now I'm going to right click in here and I'm going to say display, and I want to see the world origin, okay? And if I move this up and I zoom in, and we can see the world origin. I'm gonna have to scale this down before we can see this. Let's go ahead and scale this. So click here on the box here. This is the node inspector, and let's go ahead and scale this down. It must have been created with vastly different units because who would want a 31.6 meter wide diamond? All right, so I'm gonna scale this down to maybe 0.001 even, maybe. Let's try that. And then 0.001 and 0.001. We'll see how that looks once we get it in the scene. And then I'm going to double click on diamond over here in our hierarchy so that we can get back to it. And now I think this is going to be way above our world origin. Oh yeah, I can put that back down to 0 right here in our position and then click on it. Alrighty, here we go. So now we are able to see our world origin. So it's the more faint green, blue, and red lines. Okay, so that's our world origin. Okay, so we have our first model that we'll be able to use inside of our scene. Okay, so you saw me like kind of fiddling around in here, and that's what you're going to honestly do quite a bit here in the interface builder when you're trying to get your models just right. Working in 3D can be a little bit difficult if you're just starting out with it. Trying to keep track of world origins and orientation, just to kind of give you some tips. Left click will let you kind of pan and rotate. If you have a mouse, then the scroll wheel will translate. And then if you have a trackpad, pinching in and out zooms in and out, okay? And then we'll take a look here at these inspector windows. Here we have the node inspector, and we can change between local and world editing space. We can change the position like you saw me doing here, as you can see the Y changing, okay? And then we can change our rotation with our Euler angles here if we wanted to do that, and then our scale, of course. Over here we have the geometry. You probably won't do too much in here. And then here we have our materials, and this is where we can change the shading. This is where we can change the base color. And I want to change our transparency to be a little bit transparent, because diamonds, you can kind of see through them a little bit. All right, I think that should be good for now. We'll see how it looks once we get it added in the scene and come back and make any adjustments that we need to. All right, so now let's go get that heart, shall we? So I'm gonna open up Safari again, and I found one that I really liked here on Turbo Squid, and you'll probably need to create an account to be able to download any files from here, but I'm gonna search for heart, and there are a lot of anatomy models here on Turbo Squid. Let's see, what did I search for last time that was able to get it for me? I guess we can narrow it down by searching for free here. And then let's see here, yeah. And then you can, here on Turbo Squid, you can filter by price or by formats. So we know we want a .dae or a .obj. So I'm gonna search for .dae as well as where did obj go? Oh, right there, .obj. All right, and that gives us these. And I liked this one right here, so I'm gonna go ahead and click on that. And then we are going to go ahead and download. And I should say that I don't know all of the licenses for these, so read through them yourselves. I'm only using these for educational purposes, so don't throw any of these in any commercial apps without checking to make sure that you are able to, all right? So here I'm going to say show all, and we have a couple of versions here, 3ds Max, Autodesk. We want the .obj one, okay? So I'm going to click on that, and that's just going to go ahead and download. And I'll throw this on the desktop and we can take a look at it. All right, so we have a folder, heart_lp-2. Let me rename that real quick to just heart. And then here inside we have a .png. We can open that up. And this is a texture, okay? So if you remember back when we were working with the ship.scene, it had a texture as well. Okay, so we have a texture and a .obj file. So I'm gonna rename those real quick. Rename the heart.obj. The texture can stay the same, but I'm gonna grab those and then, well, let me open Xcode back up. Okay, so I'm gonna grab both of those and toss those in our scene assets folder. All right, very good. So now we have our heart.obj file. Same thing, I'm gonna go ahead and just edit this and convert it into a scene kit. I'm gonna convert. And there we go. So now we have a heart.scene file. I'm gonna rename this node to heart. And then let's check out our materials here. And let's change our diffuse to that heart_lp.png texture that it came with. All right, and then you still probably won't be able to tell because we don't have any light sources or anything in this scene. But if you did use this, you would be able to see the texture and the red. But we can see it right here if we again go to our scene inspector and select a procedural sky background, and then we can see the colors. All right, very good. All right, and again, this is just a ginormous heart, and we are going to scale it down. Let's try 0.002 is what worked well for me when I was creating the app. So let's go with that. And then I'm gonna double click on the heart and we'll bring it back down. And there we can see our world origin. So I think that'll be a pretty good size. All right, awesome. So that is how we can go and find 3D models without actually having to be a digital artist. You know, we have these sites and resources available to us. Obviously, the free resources aren't the very best, but so if you're going to be doing something for a commercial project, you might need to, you know, spend a little bit of money to get the model that you need. And these are just the 3 that I found. If you know of any really excellent resources for getting 3D models, free or paid, then please let me know in the comments for this lesson, and I'll get those added to the article in the next lecture that will be a compilation of places you can go to get 3D models, all right? And that will help out all of our other students as well. All right, so I'm back here in Xcode. Let's go ahead and see one of these, shall we? So I'm gonna open up our view controller here. And we're gonna create a few variables to hold our shape nodes, okay? So I'm gonna create one, I'm gonna call it var heart node. And this is going to be of type scn node. And we're gonna make it optional. And then I'm going to say var diamond node, and that is going to be of type scene node optional. And I'm making it optional because we may or may not be able to detect it. You may only detect one at a time, etc. So these are going to be optional. Then here in view.did_load, I'm going to get the scenes. I'm going to create variables for the scenes. So I'm going to say let heart scene equal scene scn scene. So if you remember from working with the ship scene, all we got to do is use the name and we provide the path to it. So I'm going to say art.scn assets / and this is heart.scn. Oop, don't forget the T. Okay, then I'm going to say let diamond scene equal scn scene, and that is going to be found at art.scn assets / diamond.scn. Okay, let me just double check I spelled those right. Looks good. Okay, so now we have a heart scene and a diamond scene. So that's good. So now let's go ahead and assign our heart node here. So I'm going to say heart node is equal to, and we are going to get the model, the node, from our scenes. So I'm going to say heart scene, and then we're going to say optional dot root node. And I can go with root node because we know that there is only one node here in this scene. Okay, so heart node is equal to the heart scene's root node. The diamond node is similarly equal to the diamond scene dot root node. Alrighty, so this one is running a little bit long, but I just want to get one of those shapes showing up. So you know what we're going to do? We are going to come down here to our renderer. All right, so I want to get one of those shapes showing up. So I'm going to go ahead and use one of those heart or diamond nodes that we assigned up here. Now, this is going to be optional, so we're going to need to unwrap it first. So I'm going to say if let shape node is equal to, and let's go ahead and do the heart node first. I'm going to say heart node. So if that exists, then we're going to add it to our node. So I'm going to say node.add child node, and let's say shape node. All right, so let's go ahead and run this and see if this works. All right, so let's check this out. Ooh, looky there. We are displaying our heart on the King of Hearts. Check that out. That is so cool. I love this AR stuff. Alrighty, so let's go ahead and finish this video up. In the next lesson, we'll figure out how to make it so that we can detect the shapes on both of our cards, all right? So I'll see you in the next one. Welcome back. In the last lesson, we got our 3D models, added them to our art.scene assets, and we were able to see our first 3D model showing up on top of our King of Hearts. Now, before we move on, I just want to do a check on our diamond node, and I just noticed a typo on that, so let's go ahead and fix that. I'm gonna right click and say refactor and rename, and just fix that. And then let's come back on down here, and okay, yeah, let's go ahead and run this and make sure that the diamond is showing up and that it's sized about how we would like. We might need to make some minor adjustments. Oh, hey, that actually looks really good. Yeah, I think that's about perfect, actually. We'll see how it compares with the heart when we get them both showing up. But yeah, for now, that looks pretty good. Alrighty, so what are we doing in this lesson? I'm gonna go ahead and delete these 3 lines. And what we need to do is we need to make it so that we can differentiate between the images here in our node 4 method so that we can know which shape to assign to which image node, okay? So what we're gonna do is we're gonna do some ifs here to determine which one we have. And so I'm gonna create a temporary node here. So I'm gonna say shape node equal to scn node, and then we need to know which anchor we have, okay? So this image anchor has a property called reference image.name, okay? And if you recall, when we imported our assets, we gave each of our images a name, okay? So we have king and queen. And we can access that property right here. So I'm going to say if image anchor dot reference image dot name is equal to, and I'll say king, then we are going to set our temporary shape node equal to the heart node. Else the shape node is equal to the diamond node. Then we're going to need to unwrap that shape node. So we're going to say guard let shape equal shape node, else return. And normally we would just return out of a function, right? But this method requires a return, either an SCN node or nil, okay? So if we were not successful in getting a shape node, then we're just going to return nil. However, it should work. So we're gonna say node.add child node. So now we are adding to our main node, which is the image node, and we are going to add our shape node to it. Or I should say we're adding our shape to it, the unwrapped version. All right, that looks pretty good. Let's go ahead and run this and test it out. I'm excited. Alrighty, so we got our 2 cards here. I'm gonna flip over our queen and boom, there we have the diamond. All right, let's see if the heart shows up as well. And there's the heart. All right, that is so cool. Wow. All right, great work so far. Tracking is pretty dang good. You'll notice that if you go at too much of an angle, probably about 45 or so, you lose the tracking, but it's pretty darn good. All right, so this is fine how we have these if-elses, but if you decided to add more cards, you would pretty quickly get a pretty nasty if-else, else-if, if-else, else-if. So let's go ahead and turn this into a switch statement. But first, another thing that I want to do to kind of help clean this up a little bit is to create an enum, an enumerator for our card types. So down here at the bottom, I'm going to create that enumerator. So I'm going to say enum, and we're going to call it, let me scroll down here, card type, okay? And this is going to have a type of string. And our first case is going to be king, and that is going to be equal to the string value king. And then our second case is going to be queen, and that is equal to the string value queen. Okay, so now if you decided to add more cards, you could just say case ace is equal to ace, case jack, etc., etc., and you'd be able to pretty easily and cleanly add more types. Okay, so now we're going to go ahead and clean this up a little bit right here, and we're going to say switch, and we're going to switch on the image anchor.reference image.name. Okay, so we're going to be switching through the different possibilities that this can return. Okay, and so our first case, we are going to say case, and we're going to access our enumerator. So I'm going to say card type dot king dot raw value, which is a string, and then we're going to say if that is the case, then we're going to say shape node is equal to heart node, and then we're going to add another case. So case card type dot queen dot raw value, which is the string queen. Then we're going to set shape node equal to diamond node. And then because switch statements have to be exhaustive, which means that we have to cover every possible scenario, we'll just add a default statement and break out of the switch statement. Okay, and I like that better. I think that's cleaner, is more able to be expanded later on in a clean way. All right, so that's looking pretty good. Let's go ahead and run that and make sure it's still working. All right, perfect. That is indeed still working for us. And let's see here. What do you think about the size comparisons between these two? Maybe should we make the diamond a little bit taller? A little bit bigger? Let's make the diamond just a tad bigger, all right? Let's do that. All right, so let's come over here to the diamond.scn file, and let's go ahead and maybe say 0.015. Okay, we'll make it just a touch bigger. Oh, it jumped to 0.2. I guess we can't go to that many significant figures. All right, we'll see how that looks. I want to check out our materials though. It doesn't look like our transparency worked, and that's because I think I set the wrong thing. So I'm going to set this back to what it was before, and I think what we want is actually here. Yeah, right here in the node inspector here under opacity. That's what we actually want to change. So I'm going to drop that down to 0.8. Then let's see what it looks like if we give this a slight blue color. And drop the opacity on it. Let's see what that looks like. Let's run that. All right. Yeah, I think that looks a lot nicer. Very cool. I think we do need to raise up our models just a touch. I think that would look better. And then we're going to make it look really cool by applying a rotation action, all right? All right, so let's check out our origin here. We can see the world origin here. I'm going to raise this up. Let's check out our position here. And let's put that up to about 0.08 there. That looks good. And let's check out the heart.scn file. And same thing, we're going to grab it and move it up to about 0.08 as well. All right, now let's jump into our view controller and let's go ahead and give our shape node a rotation. Okay, so I'm going to create a shape spin. This is of type scene action, which we've done many times by now. Hopefully you're not sick of it. So I'm going to say 0 and 2 times dot pi. So this would translate to 360 degrees, and then 0 degrees around the z-axis. And let's go ahead and do a 10-second duration on that, nice and slow. Then we'll say let repeat spin because we want it to continue to spin. We'll say scene action dot repeat forever, and we'll pass in the shape spin scene action. All right, and then we just need to set that for our shape node. So I'm going to say shape node dot run action, and we are going to pass in the repeat spin. All right, and let's check that out. Oh, it's so beautiful. All right, I think the heart is too high though, probably by about twice as high. So let's go ahead and fix that. All right, let's change it up. So our heart was a little too high. So let's go ahead and grab that and drop you about to 0.04, and we'll see how that looks. A little better. I think we dropped it too far this time though. So let's move that back up a couple. All right, let's go up to 0.06 and try that. Man, now it's too high again. All right, I'm gonna fiddle with this until I get it just right, and I will tell you what to put. Alrighty, I think that right there is pretty darn good. Beautiful. All right, so the value that I ended up with is 0.046. So go ahead and try that out, and hopefully that works perfect for you too. Alrighty, so in this lesson, we learned how to differentiate between image anchors by accessing the referenceImage.name property, which is a descriptive name for the image that we give it when we add it to our AR resources folder right here. All right, and so using that, we are able to apply different properties. In our case, we're adding different shapes to each different image. And then we gave it a nice little spin action to give it some animation and make it look really cool, all right? So in the next lesson, what we're gonna do is we are going to learn how we can tell how far apart they are and perform an action when they get close together, all right? So hope you're excited for that, and I'll see you in the next one. Welcome back. This is where we left off in the last lesson. We made it so that we could differentiate between our image types and added a nice little spin rotation on them. Now what we're going to do in this lesson is make it so that we can know when our images become close to each other within a certain range, okay? And one thing that I noticed that I want to fix here is that if we get to this part right here, we're going to return node here. But if we did not get the image anchor as we expected here in our if let, then here we are going to return nil. Okay. All right, let's just do a little bit of cleanup right here. Alrighty. So the big question is, how can we know when they come close together? All right. Well, there is a delegate method called update at time, okay? And it says here, this tells the delegate to perform any updates that need to occur before actions, animations, and physics are evaluated. So if we click here, it says here that SceneKit calls this method once per frame, so long as the scene view object displaying the scene is not paused. So we can implement this method to add game logic to the rendering loop. Any changes you make to the scene graph during this method are immediately reflected in the displayed scene. All right, so that's pretty great. This method will be called once per frame, so we can do checks like how close or how far apart our cards are. So all we need to do is calculate the distance between the two nodes each frame and do something if they are close enough together. All right, so first thing that we're gonna do is we need to keep track of our image nodes. So up here at the top, I'm gonna create ourselves a new variable called image nodes. And this is going to be an array of scn node, and we'll initialize that to an empty array. And then down here, we are going to add it to our array. So I'm gonna say image nodes dot append new element node, okay? So each time we add an AR image anchor and a node, we are going to append that to our image nodes, okay? And so if we have two nodes, we only want to calculate the distance between two nodes if we actually have two nodes. So we're gonna do a check first. We're gonna say if image nodes dot count is equal to 2, then we are going to calculate the distance, okay? So similar to what we did in the AR ruler app, we are going to convert our two scene vectors into GLK vectors so that we can use the GLK vector 3 distance method to calculate the distance easily. Okay, so I'm going to create two variables here. I'm going to say let position 1 equal, and we are going to convert scene vector 3 to a GLK vector 3. Okay, and this vector is the first in the image nodes array. So I'm going to say image nodes and access the 0th element. And then we're going to pass in the position, which as you can see here is a scene vector 3 and is the translation. Okay, so we've converted the first image node's position into a GLK vector 3, and we're going to do that for the second position. So I'm going to say let position 2 equal, and that's going to be a scene vector 3 to GLK vector 3. And this is image nodes and the second image node, and we are also going to get that position. Okay, so now we have two GLK vector 3s, and we can use the GLK method to calculate the distance, and that method is GLK distance, and we want the GLK vector 3 distance, which calculates the distance between two GLK vector 3s. Okay, so the first one, of course, is position 1, and the second one is position 2. All right, so that is our distance between our two cards. So let's go ahead and just print this to make sure it's working. And then we'll do a little if statement here. We're going to say if the distance is less than, and let's do 10 centimeters, okay? So we'll say 0.10, and here we'll print out another one. We'll say, hey, we're close. All right, let's run that and test it. All right, so our cards are detected, and you can see, let me make this a little bit bigger here. You can see the distances being calculated for each frame, and as I move them closer together, the numbers get smaller and then bigger, and I'm gonna get close, and hey, there we go. Hey, we're close. So now our two cards are within 10 centimeters, about 8 centimeters to be exact. And then once we get back over 10 centimeters, we stop printing out, hey, we're close. And then we get close again, and we print it out again. All right, how stinking cool is that? Very, very cool. All right, so that is how you can determine how close two images are to each other, or really anything that you need to calculate on a frame-by-frame rate is by using this function, update at time. All right, so I'm going to delete these print statements here, and I have a challenge for you, all right? So I want you to decide what you want to do when the cards get close together, all right? You have a lot of options. You could spin them even faster. You could make them go up in the air and come back down. You could scale them higher. Anything that you can do with these scene actions. For example, scn action dot. You could scale it. You could rotate it. You could move. You could you could fade the opacity. You could do anything you want. And so what I want you to do is create a function that will call that action on these nodes. So for instance, I'm going to make mine spin and jump. So I'm going to say func spin jump. Okay, but you're going to run into something, all right? So I'm going to give you a little bit of a hint here. If you call this right here and you pass in the node and you call it on that action, remember that this method is called every single frame. So if you have an action to say make it scale larger, then it's going to try and scale larger every single frame, and that's not going to work. So you're going to have to come up with a solution to get around that, all right? So post whatever solutions you come up with, post your action function for when they come close together. And if you come up with a better solution than I did, then I will make an update video featuring your solution, all right? So go ahead and give that a shot. And in the next video, I will go ahead and show you what I came up with, all right? So I'll see you then. Welcome back. In the last lesson, we learned how we can calculate the distance between our two images by using the update at time method, which is a method that is called once per frame. All right. So now what we're going to do is add our action for when they become close together. All right. So I'm going to go ahead and write that out right here. So I'm going to make it so that it spins quickly and that it kind of does like a hop up and back down, okay? So first off, let's go ahead and do our spin, okay? So I'm going to say let shape spin equal scene action dot, and our favorite rotate by, and x is going to be 0, y is going to be 2 times dot pi, and 0 for z, and we're going to do this in 1 second. All right, then I'm going to give it the timing mode of easing in and out to make it look nice and smooth. And then we're going to have an up and down action, okay? So I'm going to say let up equal scene action dot move by, and we're not going to move in the X or the Z direction. We're just going to go straight up, and we're going to go up about 3 centimeters. I'm going to say 0.03 and then 0 for the Z, and we're going to do that in half a second, 0.5. All right, so that gets us up. Now we need to come back down. But first I'm going to add a timing mode of type ease in, ease out. And then we're going to have our down action. So I'm going to say let down equal, and we can just call up and then we can reverse it. Okay, so this creates an action that reverses the behavior of another action. Okay, so all we have to do is reverse the previous up action. And then so that we can go up and down, we're going to create a scene action sequence. So I'm going to say let up down equal scene action dot sequence, and we are going to say up and then down. All right, so now we need a node to add these actions to, right? So what we're going to do is we're going to pass into our spin jump function the node for each of these. So I'm going to add a parameter here for our function. I'm going to say spin jump node, and we're going to pass in an SCN node. All right, so then when we call this right here, we are going to pass in the image nodes, and I'll pass in 0, and then I'll call it again for the second node, and we'll call that one. Okay, so one thing to remember here is that this node here, this is this node right here, okay? So it's not the actual shape node that we want. All right, and so this is where we can talk a little bit about hierarchy, right? So we have this node, and we added a child node, which is the plane node. And this goes into an array of this node's children, okay? So we have our first child node. So this is going to be, so the plane node is going to be a child node at the 0th index of the parent node's child nodes array. And then we added the shape node as the second child node in this node's array. So down here, when we get this node here, this is the image node. So we need to get the shape node. So I'm going to say let shape node equal, and then node dot child nodes, and we're going to access the second or the index 1 node, which would be the shape node. Then down here, we are going to say shape node dot run action, and we're going to pass in the shape spin, and then we're going to say shape node dot run action, and we're going to pass in the up down. Okay. Now you may be thinking, hey, didn't you warn us about something in the last lesson? Well, I'm going to show you what happens if you don't implement a safeguard for each frame here. All right, so let's see what happens. All right, so we have our two cards. And as we become closer, you see that they just flew right up. So it's not quite doing what you might expect, is it? I mean, it looks kind of cool still. So they keep flying up until we pull them apart and then they come back down. So I mean, still cool, but not quite what we are looking for, right? So what I'm gonna do is create a variable up here, a class variable. I'm gonna call it var is jumping. And we're gonna set that equal to false. All right, so this is a variable that's going to keep track of whether or not we are in the process of doing the action for when the two cards come close together. So we're gonna start out with it false, and then if we get close together, I'm gonna set it equal to true. So I'm gonna say is jumping is equal to true. And then I'm gonna say else here. So if we're less than 10 centimeters, then we're gonna execute this. But once we get farther apart, then we know that we aren't going to be executing that jumping. So I'm gonna say is jumping is equal to false. Okay. And then down here in spin jump, if we are currently in the process of a previous jump, then I'm just going to return out of this function. So I'm gonna say if is jumping, then I'm just going to return, okay? All right, so that should fix that problem. Now let's go ahead and test this out. All right, so I got my two cards here. Here's our queen and our diamond, very nice. And our heart. All right, cool. All right, so I'm gonna bring these close together and we should see it. Ooh, yeah. Do a little spin jump. Very cool. That looks so awesome. Alrighty, so that is it. That is the end of our Hearts and Diamonds app. We have learned a lot. We learned how to add images to be detected. We learned how to add 3D models, where to find them, how to add them to our project and convert them, how to apply textures. We learned how to add game logic during each and every frame. We can do a method check. And I hope you guys had a lot of fun with this app. Keep on adding to it. Add different cards like the ace and the jack and all the other cards, and just have a lot of fun with it, all right? And show us what you've done. Leave screenshots in the Q&A. Tell us how you're doing, all right? So this has been Johnny, and I'll see you in the next one.